Hello children, this is Ashwini from Cheenta.com. Today we will be working on a problem from coordinate geometry. This problem will help us to understand how to look at higher degree polynomials, just like this one, x cube plus y cube equal to xy times 1 plus xy. How to look at polynomials like this and figure out what type of shape, what shape do they represent. This type of problem often comes in ISI-CMI entrances or the step entrance of United Kingdom, or you can also use intuitions like this for mathematical Olympiads like American Math Competition, ISI-CMI and so on. Let's first look at this problem from an algebraic point of view. We have x cube plus y cube equal to xy times 1 plus xy. Let's bring everything to one side and we will try to factorize it. Okay, it's actually not that hard. X cube plus y cube minus xy minus x squared y squared equal to 0. Now, by inspection, by observation, and if you have been practicing factorization for some time, you will immediately see that this can be factorized actually. You have to pair it up correctly. So, x cube minus xy plus y cube minus x squared y squared equal to 0. Now, from these two, let's take x common. So, we have x squared minus y. And from these two, let's take minus y squared common. So, we'll have x squared minus y again. Okay. That's great. Now, we have x squared minus y in both of these pieces. So, we have x squared minus y times x minus y squared equal to 0. What this essentially means is we have two factors and the product of these two factors is 0. How can that be? Well, product of two things can be 0 if one of them is 0 or the other one is 0. So, we either have x squared minus y equal to 0, which means y is equal to x squared, or we have x minus y squared equal to 0, which means x equals to y squared. So, either this is satisfied or this is satisfied. Now, if you have been working on coordinate geometry for some time, you already know that these are actually equations of parabolas. These are equations of parabolas. Okay. So, let's see how we can draw them. We will draw the x and y coordinates, the x-axis and the y-axis. And let's first do y equal to x squared, which is simply this particular picture. And then let's do x equal to y squared, which is simply this particular picture. Now notice there are 2 points of intersection, which is 0, 0 here, 0, 0, and again this one, 1, 1. You can do this by inspection, or you can just plug it into the function that you have. So you will see if you plug in x equal to 0, y equal to 0, it will satisfy. If you plug in x equal to 1, y equal to 1, that will also satisfy. Of course, you could make, an algebraic attempt to solve these two equations. To find the points of intersection, solve these two equations. So, I'll give you a challenge problem. Can you algebraically solve these two equations and show me the working in the comment section and tell me what is the value of x and what is the value of y that satisfies both the equations. Okay, so give it a try and let me know in the comment section. I hope you like this problem. Whenever you see a higher degree polynomial, try to factorize it and set each of the factors to 0, and you will immediately get the entire picture, the total picture that that particular polynomial represents. It's usually a pair of curves. Okay, so I hope you learned something from this one. Thank you for watching, and I'll see you in the next one. Bye.